Hello, welcome to the Broadhouse. In this video, we're going to examine and polish limestone with fossils, and after that, we'll take a closer look with a microscope. When we lived in Florida, I collected a good bit of fossiliferous limestone, and I'm finally going to polish a piece. We cut a few pieces in half, and you can see some of this limestone is coarse-grained and made almost entirely of fossil fragments, and other pieces have this fine-grained matrix, almost like a hardened gray mud. I need to pick a piece to polish, and I'll be looking for one with that fine-grained matrix. It will be more stable and less likely to have bits of fossils chip out. A thin rock with significant cavities like this one is risky. To get the surface ready for polishing, I have to grind the rock down to the deepest point of each cavity. That's why it's important to select a thick, chunky piece like this one. The rock is going to shrink as I grind away material to smooth the surface. It needs to be thick enough to withstand that and still have enough of a core left to polish. I think this piece will be the one, but before I get to work, I want to show you my favorite thing about these rocks. Sometimes it's there as solid crystals, and sometimes it comes from the remains of ancient sea creatures whose shells were made of the same stuff. It's calcite, and in this case it's fluorescent, which means it glows under UV light. That glow happens because certain elements within the calcite absorb invisible ultraviolet rays and release the energy as visible light at a longer wavelength, which is why it appears as a different color. Since limestone is mostly made of calcite, it offers many chances to witness fluorescence under UV light, and that's my favorite thing about fossiliferous limestone. There's nothing wrong with my 200 series Dremel, but it only has two speeds, 15,000 and 35,000 RPM. So when I saw that the 3100 has 5 speeds, ranging from 5,000 to 35,000 RPM, I had to get one. Using lower speeds should reduce bouncing, which can damage the rock. It will also reduce heat, and this, along with less bouncing, should help the Dremel bits last longer. If you want to check out any of the tools I'm using, I've got links for everything down in the description. Even though I'm using a water drip, I still wear a respirator. I also wear safety glasses and gloves. And this is a plastic container with a bottle brush screwed to the bottom for scrubbing and rinsing the rock. My plan for this one is pretty simple. I'm going to leave the top alone and preserve as much as I can. To shape it, I'm using a diamond grinding drum, and I'll be staying on the lowest speed of 5,000 RPM. A couple of people have suggested that I use a flex shaft because this much water near an electrical tool is dangerous. That's a good point, and I will be getting a flex shaft as soon as possible. If you're wondering where this water is coming from, I put a link in the description for a video that will show you how we built our own water drip system. Limestone, shells, and calcite are all relatively soft, so progress is quick. The hardest part about shaping this rock is grinding away all of the outer fossils, and I mean it's hard emotionally. I know I'm revealing more of what makes this rock special by bringing hidden fossils to the surface, making them easier to appreciate and study. But I'm also destroying pieces of ancient life, turning the remains of creatures that lived millions of years ago into dust. And that's hard to do when you recognize the magic of time and nature. This is flat enough to move on. Right now I'm just working towards a rough shape, and once I achieve that, I'll be going back over everything to smooth it out and get it ready for polishing. This is sad, but I did document the fallen fossil warriors that lost their battle with the Dremel. They are gone, but now they are not forgotten. It looks good so far, but I've come to a difficult side. Normally, I wouldn't save the biggest side for last, but this one is tricky. It has high peaks, low dips, and it's just shaped weird. I like to stay as close to the rock's natural shape as I can, and that's easier to do when you save the weird sides for last, because at that point, the rock has a near complete shape to blend into. This is really cool. There's half of a bivalve fossil sticking out right here. The Smithsonian Handbook of Rocks and Minerals says this limestone can contain a great variety of brachiopod and bivalve shells, and thanks to the University of Kentucky, I learned how to tell the difference, and it's a difference in where they are symmetrical. This curve near the hinge here means it wouldn't be symmetrical if you were looking at it from the top down, like it would if it were a brachiopod. Grinding on this bivalve fossil is painful. I want to keep as much of it as possible. To help me do that, I'm going to work down the areas around it and then blend the fossil down to that level. This area of the rock ended up being pretty problematic. I've been calling it the boneyard. There's a lot of fossils and not much of the gray matrix to cement them together. Because of this, pieces are breaking away quickly. But this also means that it will be challenging, maybe even impossible, to achieve a uniform surface without pits left from the fossil pieces that get knocked out. But we'll cross that bridge when we get there. Right now, let's take a closer look at this bivalve before grinding it up. I've been looking at bivalve anatomy diagrams trying to figure out what I'm seeing, and I started to notice a familiar feature. What are these? I think they are gills, specifically the gills of a Eulamellibranch bivalve. So these dark spots were actually the water-filled cavities in the gills of the most advanced and most common type of bivalve. Something cool about bivalve gills, they are multifunctional organs. They are the main respiratory tissues, but at the same time filtering organs which collect food particles from the water column and transport them towards the mouth. Okay, look away if me destroying this fossil is gonna make you sad. I wish I could. Now that that's done, I just need to work down this peak and we'll have the shape for this side. The shaping process is not complete yet. I still need to go back over everything to get it smoother and ready for polishing. And while I was doing that, the sun moved in and messed up the exposure. By the time I noticed, I had already completed much of the final shaping. We've been working outside in this portable shelter, and it has to be open on both ends when it's hot outside. The sun was becoming a problem for recording video, so we got these clamps that allow the door to hang lower, and that took care of it. I just need to finish this little side and then we'll move on to final shaping. Here's all of our fallen fossil warriors after 2 days of shaping. And here's where we're at with the rock. I'm not loving this curve here, but I can't do too much about it since it holds the brittle boneyard and I want to keep as many fossils as I can. I'm just going to take my time, use very light pressure, and see what I can do. This is a tactile hobby, and sometimes my gloves get in the way. I'm gonna lose the gloves, so I have an easier time locating high spots. I'm still going very slow and gentle and stopping often to check the progress. Unfortunately, video quality is becoming an issue again. There's a lot of water flying around at all angles, and I'll be honest, sometimes I'm not great at noticing how dirty the lens gets. I don't want to show you a bunch of bad quality video, so we'll just move on to final shaping. I'm going to clean my work area before moving on because I don't want coarse sand or fossil pieces making their way back onto the rock and potentially scratching the surface during polishing. Nice and clean, and I also grabbed a microfiber cloth to keep with the camera to clean the lens. Okay, let's get polishing. As always, I'm starting with a 60 grit sanding disc and staying on the lowest speed, which is 5,000 RPM. I'll be giving the rock a good scrub with a firm toothbrush in between each grit, not only to clean out any holes or crevices, but also because if a fossil fragment falls out, I'd rather it come out now when I don't have a tool spinning around on the rock, because that could scratch it. Moving on to 80 grit. Then 100. $150. $240. $400. Is this a good time to ask you to subscribe? I'm still scrubbing after every grit. Keeping the rock as clean as possible really makes a difference in the final result. It's a step you don't want to skip, especially if you're polishing without a water drip. Next is 800 grit. And then 1200. $2,000. $3,000. $5,000. And finally, $10,000. One last scrub, and then I'm going to let it dry. And here it is. Mineral oil will make it glossier, but this is the final result of the polishing. I don't think I've ever polished limestone or fossils before. I expected the shells to polish well, and I'm really glad the rest of the rock did too. I'm also really enjoying the contrast between the raw side versus the polished side. This rock has a lot going on, so let's take a closer look with the microscope. With all of these things layered together and dissected at different angles, it's really hard to know exactly what we're looking at, where one fossil ends and another begins, and what is this? But some of this is very familiar, like all of the broken shells and calcite, and also crystals, which seem to be growing in every available space. The boneyard looks about as I expected. Deep valleys and pits and highly polished peaks. But I wasn't really expecting to see the calcified cross-sections of so many different creatures. And what is this? Is it part of this animal or something it ate? The shells are made of calcite and they're full of calcite. I'd be silly not to try and get some UV shots, right? The change of color is happening because calcite is a fluorescent mineral. If you missed the explanation earlier, fluorescence happens when something absorbs light at a particular wavelength and then quickly re-emits that light at a longer wavelength. That's why it briefly appears as another color. Here's a nice group of calcite crystals for us to look at with the UV light. Check out this neat speckling effect. I wonder why that's happening. And why is the material in this shell blue? It looks like a snail shell. Snails are members of a very successful group of animals called gastropods, and these fossils are anywhere from 65 to 1.8 million years old. This is what life turns into. This is the magic of time and nature, a never-ending cycle of transformations. The unpolished side was pretty cool too. I was really surprised to see green living moss. I'm not sure what these dark circular spots are. I would love it if anyone could tell me. And what's this? A calcite crystal-filled bivalve fossil? Of course we're going to hit it with ultraviolet light. And this is how big it is, with a pencil tip for scale. Well, I'm almost done with this rock. I'm just going to rub it down with mineral oil and a piece of denim and then let it dry overnight. Mineral oil cleans the rock and provides a thin protective layer. It also enhances the shine and color contrast, and sometimes it even helps disguise imperfections. And here is the finished fossiliferous limestone. So the surface isn't perfectly smooth. I knew that would be the case when I started grinding away here. But I really love this. It's such an interesting and unique piece, and I got to learn some cool things about gastropods, like this one that we looked at under the microscope with a UV light, and also bivalves, like our friend from the beginning that we sadly had to grind away. As I mentioned at the beginning of the video, my favorite thing about this limestone is all of the opportunities to see the fluorescent property of calcite. But calcite can also be phosphorescent, which is similar to fluorescence, except the glow lasts a bit longer. A well-known example of phosphorescence are the glow-in-the-dark stars we all like to see on our walls and ceilings. I think this is the neatest thing I've ever polished, and it's a gift for a friend. I really hope she enjoys this. Before I go, let me show you how it looks outside in natural light. Okay, that's it for this one, guys. Thanks for watching, and please, subscribe to our channel.